August 15, 1977, at 22:16 UTC, Big Ear in Ohio logged a 72-second signal at 1,420.4056 megahertz. 3 days later, astronomer Jerry Emmon bent over a fan-fold printout, circled 6 characters in red ink, and wrote one word in the margin. Wow! At first, it looks like a lucky burst, one strange line in a long stack of paper. Then the frequency pulls you closer because 1,420 megahertz sits on the hydrogen line. That matters for a plain reason. Hydrogen fills the galaxy, and radio astronomers had long assumed any deliberate beacon might choose that quiet, universal marker. The code itself looked small enough to miss. 6 EQU. J5 was not a word, but a step pattern of rising and falling intensity printed by a machine that did not care what it had found. Then there is the 72-second window. Big Ear did not track objects by turning. Earth's rotation carried the sky through 2 fixed beams, and a real, distant source should drift through 1 beam on that timescale. That seems to help. A narrow source crossing a fixed instrument fits the length almost perfectly. But there is one problem. The signal appeared in only 1 beam, not both, which left a gap exactly where confirmation should have been. So the question shifts. You stop asking whether Big Ear heard something strong and start asking what kind of source can fit the telescope and still dodge its second look. The bandwidth narrows the field again. The signal was extremely tight, concentrated in a sliver of spectrum that natural radio sources rarely hold. That appears to rule in design. Narrowband coherence is what engineers build, not what stars usually spill, but the drift complicates it. The recorded frequency did not sit with the clean, stable behavior you would expect from a nearby transmitter nailed to Earth. Terrestrial interference was the first easy suspect. A ground source can leak into a receiver, stain a printout, and vanish before anyone notices. Yet the details resist that comfort. The frequency sat near a protected astronomy band, the shape matched a sky transit, and no local source was ever identified. Satellites offer another neat answer. Metal in orbit can flash, cross, and disappear. But in 1977, no known satellite fit the position, the frequency, and the timing cleanly enough. The list of candidates kept thinning. Known astrophysical sources fare no better. Pulsars pulse across broad ranges, masers spread differently, and random cosmic noise does not usually arrive as a single sharp line. For a moment, the paper looks less like an anomaly and more like a message stub. 1 line. 1 frequency, 1 pass. Then the silence returns. Follow-up searches swept the same patch of sky, and the signal never came back. That absence is not a footnote. Repetition is how astronomy turns curiosity into evidence, and here repetition failed. 1 sheet of printer paper carried the whole case. No audio tape, no image, no second capture, only ink, numbers, and a red circle. That fragility changes the scale of the mystery. The strongest candidate for extraterrestrial contact rests on office paper thin enough to fold. In 2017, a new explanation arrived from hydrogen clouds around comets. It offered a natural source near the right part of the spectrum. At first, that sounds like relief. A comet sheds hydrogen, hydrogen radiates, and the old signal settles back into ordinary sky. But the fit is loose where it matters most. The proposal did not reproduce the original narrowband structure, the exact intensity profile, or the singular 72-second event as recorded. It also leaned on later observations, not the 1977 detection itself. A similar ingredient is not the same thing as the same signal, so the question changes again. It is no longer only whether a comet could glow near the hydrogen line, but whether that glow could mimic the printout so precisely. And the printout remains stubborn. 6. EQUJ 5 still rises like a source entering beam center and falls like a source leaving it. That shape argues for geometry, not accident. Something crossed Big Ear's field in a way the machine recognized. Then you hit the wall that has held for decades. If it was distant, why only once? If it was local, why this clean? The oldest clue is still the sharpest one. Jerry Amon did not discover a theory. He discovered a line of data that refused every tidy drawer. A red pen in the margin gave the event its name, but not its meaning. The ink lasted longer than the explanation, so the harder question is not whether Earth heard another civilization for 72 seconds. It is why the closest thing to contact in human history still survives as a signal that rules out so much and proves so little. All persons named are presumed innocent until proven guilty.